All right. We actually still waiting for Ron to appear, but meantime, any volunteers to take minutes? Please. Ah, come on. Okay, I'll give you a few minutes to think about it. So, I don't know if we shall wait for Ron. I was going to say it's going to be a very short meeting, but I know it's famous last words.
We should make the next person who joins be the meeting taker.
Yes, I was thinking about that. Yes, it's actually a good idea, but we need this should be automated feature of Meetecho, right? You press the button and whoever joins next should be automatically assigned as a minutes taker. Thanks, Florence. Appreciate it. Hopefully it's not going to be too much of a job today. And everyone who says something at the microphone could later take a look and update the minutes. Thank you very much. So, I don't know, probably. I don't know if Ron is missed induction. Okay, let's start with housekeeping anyway. So welcome, operational security capabilities for IP network infrastructure. Is it the longest working group name at IETF? OPSEC for short. Note well, I think everyone has seen it before, many times this week, but just in case, if you have not, please take a look. I decided not to put the slide about Meetecho. I mean, with all these links to Meetecho and so on, because I guess if you're hearing me now, you already know how to join this session. However, housekeeping. I would appreciate if you keep your audio and video off, unless you're actually speaking, you're either presenting or join the queue. And to join the queue, you press this raise the hand button, wait for your turn, then you start sending audio and video if you prefer. And after you're done with your comment, please leave the queue. Yes, Florence, I'm looking at the chat. Yes, it's a note-taking tool at the top right, yes. Just use this. So we have this shiny feature of using preloaded slides. So Oli, let me know if you don't want to use it, but otherwise I assume we can use this. Florence already volunteered. Thanks very much for take minutes. But if you say anything today, please take a look at the meeting minutes after the session to make sure everything's been captured accurate. We haven't been meeting for a while, and today we have quite a short agenda. We have one presentation. Actually, sorry, this slide is not accurate. It's not Kirsty who will be presenting, it will be Ole. And working group business. Yes, as I said, we haven't been meeting for a while, so we have not published anything. However, two drafts which been and as a working group business for a long time, finally seem to make significant progress. Operational security considerations for IPv6 networks are currently with RFC editor's queue, already has RFC number and so on, so stay tuned for it being published. And IPv6 extension headers filtering and transit routing is currently going through ISJ evaluation, and I can see a lot of area directors' comments on the draft. So hopefully we can finally publish this one as well. So I think it's all I have for today. Any last minute agenda bashing? Anyone has anything to present suddenly? We have time. No one. Good. So, Oli, the floor is yours. Would you like to use pre-shared slides?
Yes, please. Yeah.
So yeah, then you can, send the request. Click on the. I should stop sharing, and you. Yeah. Okay. Sorry, my bad.
Okay. We will get there, I'm sure. Lovely. Thank you very much, everyone. And good morning, good afternoon, good evening, wherever you are on the planet. Isn't this amazing? So thank you very much. My name is Ollie Whitehouse, and I'm the Group CTO at NCC Group, and I'm one of the co-authors on this proposal with Kirsty around indicators of compromise. And we wanted the opportunity today to kind of rewind and kind of give you an overview of the process that we've been on, the purpose and the intent, and then ask a couple of questions as we get towards the end of the presentation in terms of what next steps might be. So a bit of history. So it was originally presented back in SEC Dispatch, IETF111. We've now been through several rounds of iterations, taking on feedback at each stage, and actually the authors also have similarly increased. So we've added in the last iteration another co-author in the guise of James, and we brought it to the OPSEC mailing list for discussion. And thank you to Nancy and Fernando for they did a thorough review, shall we say, in 02, and that led to a lot of good discussion and further building out actually of the work itself. So really, you know, the purpose of the motivation is, and where Kirsty and I come from, you know, we're defending networks on a daily, weekly, monthly basis, and it is obviously a very challenging and ever scaling set of problems that we face there, both because obviously, you know, technology is changing very rapidly, user maturity, you know, system admin capability, etc., etc. So there are a number of driving factors which complicate the art of cyber defense more broadly. And so we wanted to provide a piece of baseline knowledge to protocol engineers specifically as to, you know, things to consider when, from a cyber defense perspective, when designing some protocols. And that we felt that was important because, you know, I think increasingly when we design network protocols, we have a set of design choices that we can enact as part of that process. And I think, you know, we see at times that some of those go against some of the opportunities there are to make our own jobs easier in the provision of cyber defense and network defense specifically. And so what we also wanted to do was bring kind of some of the practitioner from our side, and we're obviously a synthesis of a lot of knowledge both within the UK and broader, into the IETF and really try and, as I said, kind of articulate the need and the want. So kind of the draft introduction really outlines that in order to get a scaling effect in our cyber defense activities, we rely on what we call indicators of compromise, and these are often, you know, IP addresses, DNS names, etc., which can be easily transmitted and shared within various trust forums in order to detect and potentially disrupt threat actor activity at relatively low cost. There obviously come with that, you know, and you'll see in one of the latter slides, what we consider what we call the pyramid of pain. There are varying degrees of, I guess, quality, length of time that they have, efficacy for, etc., but they are all important, and they have, at the very least, a an aggregative effect on combined network defense when we roll them out. So to give you examples, we have systems that pump them out real time to hundreds of networks, tens of thousands, hundreds of thousands of endpoints, and that allows us to very quickly turn on a dime in terms of when we come across new threat actor infrastructure, or we gain intelligence through incident response, to effectively light up where that threat actor also is, and more importantly, disrupt them and eradicate them from those networks by organizations that would not necessarily be able to do so easily. They cannot procure certain services and the like. But what we wanted to do, and what we've done, is we've written quite a lengthy piece of work now in terms of the role and the importance of IOCs in network defense, how to think about them, some of the design considerations, how they're effective, and some worked case examples. So this kind of gives you shows you the journey that we've been on. So on the left-hand side was our first stab, as it were, at this, and then based on the feedback and the questions that we got in, and I have to say, very constructive criticism and helpful criticism and contributions, where we've kind of fleshed out more so the work now to kind of provide a more standalone piece of work. So I think we fell into the trap that I suspect we all do at times, where we assumed a base level of knowledge and we fell into our own vernacular, and we didn't do enough of the base explanations, and we've kind of gone through that process now as part of this work. So as I've touched on, IOCs come in various forms, and so obviously at one end we have IP addresses, v4, v6 addresses. Granted, actors can change those, but that is still used by an awful lot. The number of threat actors that will stand up their command and control infrastructure on a rented colo box in somewhere in the globe, and they'll use that for a particular campaign or operation, and so all the malware will be hard coded to that IP address is surprisingly common still, even in 2021. Obviously, we have DNS domain names, and people and threat actors again will similarly use that in order to masquerade or otherwise blend in with what would look like legitimate network traffic using a variety of different techniques. But suffice to say, again, it's a very useful tool for us to either look historically or in terms of active traffic flows, in terms of identifying compromises that may be present in an environment. Obviously, SNI on TLS, so the server name indication. So even when we can't do traffic introspection because of crypt, well, SNI is a very useful tool to still to allow us to understand, even though we can't see the content, the metadata. It allows us to understand that again, there was communication to a known suspected malicious host. Code signing certificates of binaries, TLS certificate information, again, all very useful. Actors fall into the same traps. There's a certain laziness with their operational security. They kind of get into kind of muscle memory territory. They'll reuse things where they're hard to procure. And so, for example, we see campaigns as we've had to introduce code signing more aggressively on operating systems. For example, threat actors have found ways to buy either masqueraded or stolen code signing certificates. But then the supply of those is quite finite, so they'll use it potentially across multiple campaigns. Cryptographic hashes, so of files, of other artifacts, so be it MD5, SHA-1, SHA-256, etc. And then we start getting down into kind of the more nitty-gritty, so particular tools and bits of tradecraft, and then real attack techniques. And so when we put that all together, what we get is we get our pyramid of pain, and the ones at the top are the less fragile, most precise, harder to change. The bottom ones are the most transient. Is where we get.
Sorry,
to.
Ole.
Yes.
Sorry, Ole. Sorry for interrupting. We have Eric and Q. Do you want to take questions or comments?
Please,
now?
yeah. Sorry, yeah. I should have been
Yeah.
quite happy to take questions as we go. So, Eric, please fire away.
Yeah. Can you talk a little about your threat model for SNI? As I think I mentioned on other locations, if the attacker controls the server, then SNI can't be is unverifiable.
If the attacker controls the server
and the client.
yes, if the attacker controls if the attacker controls the server,
The client and server pair, then SNI is useless.
Yes, but often, to give you an example, what we may see is why we need SNI. Okay, so they will often use content delivery networks. So we will see a connection going out to something like Cloudflare and or Azure CDN Edge, et cetera. And so the IP address is responsible for potentially many tens of thousands of particular hosts. And so we have no idea actually where the connection is going to. But obviously through SNI inspection, we can actually see that they're going to that one host that we're actually interested or that one domain that they're actually interested in. So so we don't really necessarily have a threat model for SNI. And I think you would recognize with all of these, you have a sufficiently advanced threat actor. They can probably come up, we see domain fronting being used and so domain fronting is where a threat actor can effectively tunnel through, that they can make us go blind, but that's the 1%. A lot of this stuff is to allow us to reduce the cost and increase the efficacy against the 99%.
Sure, thank you.
Does that answer your question, Eric?
Yeah, absolutely, yeah.
Okay, great. So we end up with this pyramid of pain, as I said, so invest heavily in the top and we get really precise, very low fragility in terms of the techniques, tactics and procedures, which we helpfully convert to TTPs. At the bottom end, we have things which are arguably easy to change, commodity things, so changing a file hash, getting disposable IP addresses now in 2021 is not particularly difficult. Similarly, acquiring DNS domain names and the like. So we've added a piece of work to this last release, specifically around the life cycle of IOCs, because we felt it actually useful to explain to everyone, how does it work in practice? And so obviously we go through a discovery phase where we find what we think is a suspected indicator of compromise. That will then be assessed, and then we'll do some form of sharing. So we'll do distribution of that. We often use things like the traffic light protocol, where that can be shared within certain trust groups for certain utility, because again, the fragility of some of these IOCs means we don't want the threat actors necessarily always to know that we have them, because we're using it to at least combat some of their intrusions. And then that will lead to some degree of deployment. That then results in ultimately detection of what were those latent compromises or attempts at compromise within those environments. And then we end up with a reaction, which is often a kind of a cyber defense response to either neutralizing the threat, blocking the threat, and often then what we'll see is those IOCs will degrade in terms of their value and then are effectively end of life. Because again, I think what you would recognize is domains change ownership, IP addresses change ownership, and so there is a certain finite length as to their use and utility. So I think the questions and the next steps we have for you, and obviously I'll quite happily take any further questions that you might have, but we obviously would deeply value further feedback and comments from this group, because I think what we've had so far has been extremely useful. I think we do have a question: is the work that we have been doing even in scope for OPSEC specifically? And then would you consider working group adoption? And I think that comes to the end of my slides, and I hopefully not missed anything in the chat. But do let me know if there are any other questions or the like. Sorry, Eric, do you have another question? Did you have a question, Eric? Sorry. I've got two Erics now. So Eric V, Eric V. There we go.
Yeah, sorry about it. I haven't read the draft, right? But what you just said looks like a very attractive draft, but it's more on the protocol design, isn't it, than really on operation?
Yes, I think that's a very fair. Well, yes, that's right. So what we're asking for here is as the IETF designs next generation protocols or amends existing, that these be taken into consideration, because I think you're right. You know, the intrinsic properties of the protocols will either preclude or not preclude the use or the utility of IOCs. Yes.
Okay.
We'll go to what? Yeah, thank you, Jen.
It's actually a question.
Responsible idea.
Question for Eric. Was that question sort of a slightly pointed, that doesn't sound like operations and so it shouldn't be done here? Or was that for something else?
You're right. I mean, I'm just wondering, right? So
Okay.
I was pointing in this direction, but we can be open, right? OPSEC is pretty much open. It should be open.
Eric?
I guess you know, I'm sure it's like in terms of protocol design, I guess I think informationally this is all fine, but I mean you know, we had about 3 separate documents that are all every time you encrypt something, it makes our lives harder, and you know, it's kind of like a source of frustration, I think, between sort of different parts of the IETF. So I guess you know, what outcome are you hoping for here?
Well, yeah, and I think that's right. So I think what we're asking is for optionality, if I'm being honest. So I think if I look into the world and I look at total privacy for everyone with and I run an enterprise, I make my job very difficult. Yeah, and so I think it's not asking for don't encrypt stuff. It is allowing the protocol design to be have a consideration that there will have to be a systems administrator that does have to operate and secure that environment and provide some means of optionality to allow them to effectively to do that. And yeah, and there has to be naturally trade-offs in that. And I think, you know, if you look at the DOE debates or DOT or any of those things, we see some of that today, right? Which is when you deploy that in a corporate enterprise environment, people are needing the ability to not allow DOE to be deployed in certain browsers because otherwise they cannot be compliant against some of the sectoral specific stuff, and they can't effectively defend because a whole host of threats. And and some would say, well, you just go to the endpoint and you start putting extra software on the endpoint to do that monitoring. And that's all well and good as we've got commodity operating systems where we can do that. But I think all of those around this table will recognize we have devices now that exist in walled gardens where we can't run code low enough to get the insight and the telemetry that we need. And similarly, if we look at predictions, and let alone what we're living today in terms of the explosion of embedded devices, which be damned if we can get third-party code on there. Yet we are tasked with securing it all, monitoring it all, and detecting latent breaches. And so, Eric, succinctly, optionality in some of the security properties.
I guess I don't quite understand what optionality you mean in this case. So I mean, let's take.
So if we take DOE's example is a bad example, but it's an example nevertheless, which is so I guess how would you, at the moment we have to turn DOE off, right? Or organizations have to turn DOE off if they want to do certain things with DNS over certain challenges. But there is probably smarter people than me. I don't know the answer because I'm making up off the cuff. There were probably a way of building in a way to at least do privacy preserving inspection. And I think actually we talk about it in the draft, right? So there are ways to do privacy preserving introspection in some ways without kind of knowing which websites I'm going to, but I can check for the presence of what I'm looking for. And it's building some of that in, some of that into the future design.
Well, I guess I'm pretty familiar with the cryptographic literature, and I don't I'm not aware of how to do that in any kind of reasonable way. I mean, to be honest, I guess what I'm trying to avoid is we spent literally years arguing about how DOE ought to be deployed and about people who wanted various kinds of strong statements, and what we ended up with was a working group which is designed to do mechanism and not policy. And so like it'd be very unfortunate if what happened was that those discussions basically turned into like, got basically the attempts to create policy got diverted into this working group, and then we get like most of the way to IETF last call, and it's a huge food fight, right? So like I really don't want to do that, and I don't think you want like everybody from TLS and Quick to show up here and start complaining at this draft. So so like I'm not saying this draft is bad, but I'm saying like we understand the outcome is, because the outcome is to be recommendations to protocols be designed in ways different than we're currently attempting to design them. Then that is not going to be a neutral discussion.
Okay, and I think that's a fair challenge. And yeah, if you've not read the draft, please do. And because this is the type of feedback, and we've gone at length. So multi-party computation and similar are some of the cryptographic techniques which allow one to gain, some degree of ensured privacy. Yeah, I can still search for what I want. So I sense the tension, and I'm not sure I can. So I would ask you please to look at the draft and see what we've tried to write, and see if it addresses your concerns, and if it doesn't, provide the feedback, and
Sure.
We'll take it on.
I've read earlier versions of this, so I just didn't read this 03. But I guess I would say like I'm quite familiar with MPC, and like it's not a solution to this problem. Like it's basically like we would need radical changes to like every cryptographic protocol we now have developed in order to provide the functionality you're trying to provide. So I just don't think that's like a plausible answer.
So I'm sensing that you feel that this is, to use the best phrase, a dead duck, because there's no way that we can achieve it.
I guess I don't understand. I think I guess it depends what this is. But if like what you're trying to do is like have a thing that would be, say, for instance, where I could prove that my DOE resolutions were not resolving any domain name you do not like, that would be like a radical change to every cryptographic protocol we've ever designed. So that would be like a multi-year research project. It would not be a drop-in. I'm not sure it's even possible, by the way, but it's like certainly be very, very difficult. I think that like there's a pretty stark trade-offs to be made here between like what what's available to the monitoring pieces of the network and what's available and in terms of like and what's not. I think most of what we focused on, I think, is like trying to enable people who control the endpoints to disable those things, as opposed to disable the things that are making their lives difficult. But I think that the idea that it's going to be the case that like there's some protocol we could design that would provide strong privacy against people on the network, but then would also allow other people on the network to be able to like see that you weren't going to certain like sites. I don't see how that's going to work.
Okay.
But I'll provide some comments in the draft. Like I guess if people want to spend a lot of time like writing a draft that's sort of like another draft that is like encryption made us sad, like okay, but like if it's going to turn into like a if outcome is going to be recommendation of protocol design, that seems like it's going to be very, very difficult to get consensus on.
Yeah, and I don't think that's our intent. I think our intent again is I don't think we are. I don't think we're saying encryption's made us bad, because we're still not encrypting IP addresses, right? So we have tools, right? But we want the community to at least be aware of the plight and to provide at least a reference body of knowledge. And I think that's the aspiration in the short term.
Sure. Okay. Well, I don't think that's necessarily harmful. I'll send some comments.
Okay. So no one else in the queue. So what I suggest, looks like there is some interest and it looks like useful work, right? So I would really like to see more comments on the list about the draft, and we'll figure out the best place for this work, because as a chair, I don't mind hosting it. We just need to make sure we basically, there is no better place for it, right? So if we don't find a better place, we'll run adoption call here.
Okay. Well, thank you for making time for me, and thank you.
Yeah. So please, everyone, if you have time, if you're interested, please read the draft, because I'd like to make it clear, I really don't like the situation when drafts are getting adopted because nobody said anything on the list, and it was just quiet for the whole adoption call. I don't think it usually a good reason to adopt a document. So I would love to see feedback on the draft, and then we'll go on from there. Thank you all for presenting. Any
pleasure.
last minute business? No? Okay, so thank you very much, everyone, and we can get half an hour of our live back then. Warren, did you want to say anything? Yeah.
To unmute, or just forgot to mute. Something with the buttons.
Ah, okay. Okay.
So bye-bye.
And much thanks to Florence for all of the minutes, notes, those things. Wow, I can no longer speak.